Okay, and welcome. So in this series of videos we're going to be looking at the equation of a circle. Now I love this one because this brings together a whole bunch of stuff from other areas of mathematics and just kind of mush it all together and create some fairly groovy circle based stuff. So here we go. Let's have a look at what we're going to be getting up to. So we've got the two formats for the equation of a circle. That's these two things here that look like an absolute mess at the moment, but I promise you they're not actually as bad as you might think. And then once we've got the basic equation of a circle stuff done, we've got to get into how we deal with solving problems involving intersections, lines, tangents, and normals. And we'll talk more about those in future videos. And then finally, we've got to do some problem solving built around your understanding of angles and circles, if you remember all your angle and circle rules from GCSE. So we're not going to do that all in one hit. Let's just begin with just have a look at kind of the basics of where the equation of a circle comes from. So let's have a look at the two formats. So these things here for the equation of a circle. So here comes the theory. Let's have a think about a circle. There we go. So we want the equation of that red line there. And if you think about any point on the circle, let's say with a coordinate that's x, y. And what we're also saying is we've got the radius of the circle, this distance here, we're going to just call r for now. So for our coordinate x, the horizontal distance from the origin is x. And kind of the vertical distance is going to be y, and straight away you can see there we've got a right angle triangle formed, and using a bit of Pythagoras we can see that x squared plus y squared equals r squared, and that essentially is the equation of our circle that's got a centre at 0, 0. Any point on this red line here, we can just say, okay, that distance, let's say, kind of forms right angle triangles, and so the equation of the line at any point is x squared plus y squared equals r squared. Which is nice and tidy and straightforward. But that previous one only worked for circles that had a centre at 0, 0. Let's say we've now got a circle that's got a different centre, so we've now got the centre at the coordinates AB, some values of A, some value of B. Again, we've got radius R, and again, we've got our point on the circle. So if we apply exactly the same ideas as before, you can see those arrows, so that kind of our horizontal distance, that grey distance there, is going to be all of that distance there, take away that distance there, so we can write that as being x minus a. Same principles for y, and so we've got y minus b as our vertical distance. So what you end up with is, using our Pythagoras, is x minus a squared plus y minus b squared equals r squared. And that thing there is the general equation for a circle with any given centre. Now, one thing you do need to notice, though, and be very wary of as you go throughout here, there's my mouse, here it is we've got a minus there and a minus there. Okay, so what that means is, for example, if we had a circle with centre minus 3, 2, what we've got is x plus 2 squared, because the value for a would be minus 3, that would be x minus minus 3, as we can see there. So that's why that's creating a plus 3. Okay, the other thing to watch out for is our equation here is r squared. So we've got a radius of 4, that means the value on this side of the equation is 16. Okay, so a couple of things to watch out for there, but essentially it is just Pythagoras applied to coordinates, let's say for any coordinates on this circle. Right, moving on. So it says find the equation of a circle with centre at minus 3, 4, and the radius of 5, and then sketch the circle. So straight away we know the equation is going to be of that form there. So there's our Pythagoras, x minus something squared plus y minus something squared equals something else squared. So we've got an x coordinate minus 3, so that's going to be minus 3. The y coordinate is 4, so that's going in there. And the radius is 5, so that's going in there. So clearly, as we said on the previous slide, we've just got to tidy this one up a bit, and that gives us x plus 3 all squared plus y minus 4 squared equals 25. Right, so the next thing we're going to do now is the sketch, and what I'm going to do is just pop this on the screen and then talk a little bit about what we're seeing. So there it is, there's our centre at minus 3, 4, and there's our circle, and the first thing to immediately notice is what's going on down here. Well, you will be expected to recognise that that circle would pass through the centre of the origin, because what we've essentially got here, if you look at the choice of coordinates and the radius, you should recognise that is a 3, 4, 5 Pythagorean triple. So what that means is the origin is actually 5 units away from the centre, which means the circle will pass through the origin. And in an exam, they would expect you to be aware of that. They'd expect you to be aware of whether or not the curve actually passes through either axes, where it does pass through the axes, and particularly, let's say, if it passes through the origin. The other one to think about is the y-intercept there at 8. If you think about what's happening with that one, is if we just go from our centre and come across here, what we've done there is say that, well, if that point there is a y-coordinate of 4, then that distance there will be 4, which means clearly that distance there has got to be 4 because it's a straight line. So that gives us the y-intercept at 8. Final thing we're going to do is just have a look at how we can write it in that other kind of slightly scary looking form that you saw on the title slide earlier. We're not being asked for it, but I thought I'd just chuck this bit in anyway. All that's happening is that's just coming from expanding out the bracket. So there's our x plus 3 all squared. Don't forget your middle term. Do not write that as x squared plus 9. You're always going to get the middle term coming from a squared bracket. And there's the second bracket, the y minus 4 all squared. And then all we're going to do is just tidy that up a little bit with our constant terms there, and just rearrange it a bit, and as it turns out we end up with x squared plus y squared plus 6x minus 8y equals 0. Okay, moving on. So this last question, what we've got here is the equation of the circle. Now it's given to us in this slightly horrible looking form, which is the form we've just looked at in the previous slide, and what we've got to do is find the centre and the radius of the circle, which means we've got to put it back into the format that's got the squared brackets in it. And to do that, we are going to need, firstly, to reorder things just a little bit. So all I've done is just put all the x's together at the front and then kind of put the y's together here. And then all we're going to do is use completed square. So here's our next bit of math that's coming into this. So we need completed square on the x values to get that into a square bracket, completed square on the y values to get that into a complete square bracket, and then we'll tidy up all the extra numbers at the end. So here we go. So x squared plus 2x becomes x plus 1 all squared minus 1. And that bit there becomes y minus 6 all squared minus 36. There's the 29, still on the end, we haven't done anything with that yet, equals 0. So now all we're going to do to get it in the form that we want, which is this form here, is just take all our constant terms and move them over to the other side. So we end up with x plus 1 all squared plus y minus 6 all squared equals 8. Now we've got it in that form, so we can now decide what the centre and the radius is going to be. So again, we need it in this format here where we've got all minuses, and you'll notice straight away that this one is a plus, so we've got to think a bit carefully about that. So that gives us minus 1 as our x coordinate, 6 as our y coordinate, that's okay. And then always remember that that thing there is r squared, not r, so we need the square root of 8, so the radius is 2 root 2.